Hello, and thank you for attending this virtual poster presentation. My name is Michelle Lapointe, and I will be presenting part of the research that I'm undertaking for my PhD on the desiccated yeast sentinels in some background radiation environments. This research is funded in part by Bruce Power, the Nuclear Innovation Institute, and NSERC. There has been some recent interest in the potential use of desiccated yeast sentinels as living biodosimeters for radiation. This piqued the interest within the repair group, who is interested in studying the effects of biological exposures to a sub-background radiation environment. My project hopes to determine what, if any, effect natural background radiation has on desiccation tolerance. To accomplish this, we've taken desiccated yeast samples and stored them within the repair facilities at Snow Lab 2 kilometers underground, where the background radiation dose rate is roughly 1/7 of the normal. A control group was stored in the normal background environment at the surface facilities at Nawson University. Once monthly, samples were brought back to the surface to be assayed for survival and post-rehydration growth and metabolic activity. This was done with 2 strains of yeast, a wild type and a radiation-sensitive strain, with a deletion of the RAD51 gene. This deletion renders the yeast deficient in homologous recombination of DNA double-strand breaks. After 6 months of exposure, the wild-type yeast elicited a 1.75-fold reduction in survival and no change in the other 2 parameters. The RAD51 deficient yeast, however, suffered a 2.2-fold reduction in survival, a 1.5-fold increase in post-rehydration doubling time of optical density, and a 1.5-fold decrease in post-rehydration metabolic activity. These results are fairly counterintuitive, given that the initial hypothesis was that the lower background radiation would result in less DNA damage accumulation and therefore increased desiccation tolerance. Since the opposite was observed, we propose that DNA damage accumulation within a certain threshold during desiccation may signal recovery upon rehydration by some as yet unknown mechanism.